Making the ugly beautiful. The case study we're going to use here is the Amazon case study. And what happened there was that Amazon tried to be very careful to remove gender as part of their prediction in their algorithms to avoid biasing against women in their selection criteria for interviews. But in the data they had, there was all this unidentified variability left, which they didn't find other explanations for in their algorithm. And so whenever the machine learning was let loose, it looked at the data and it said, oh, I've done it. I've identified differentiation. I've managed to find a way to identify some of the variability and to account for it. And so whatever Amazon did, it would always come back to looking at the data, seeing the variability in the data. The machine learning algorithms would learn, oh, I can separate these. It's basically separated by gender. So the fact that they're taking gender out of their algorithms didn't mean that they're taking that variability out. They'd accounted for that variability in other ways in their data, and therefore the machine learning algorithms did their job perfectly. They kept finding it again and again and again. It accounted for the variability. And so it was working how machine learning algorithms are set up to do. They're set up to identify some of the unidentified variability and to account for it. And they did it perfectly. Even if that meant that, what was desired by the data scientists, and therefore the probably wasn't what was desired by them, and so it was scrapped. That's a separate issue. This is what data scientists, we as people who work with data and machine learning algorithms are trying to do. We're trying to improve our models' understanding from the data, and we're trying to understand the unidentified variability.